Okay, so today we're going to build on what we did yesterday. We're going to talk about more the log properties. We're just going to kind of keep using them and work some problems. So we're going to start by expanding this problem. Log base 9 of x cubed times 2x plus 1 times 3x minus 1 cubed. This whole thing is the argument. Okay, this whole thing is the argument. So notice that we have three terms essentially being multiplied together. We have three factors. So we're going to break this up into three logs. So we're going to have log base 9 of x cubed plus log base 9 of 2x plus 1 plus log base 9 of 3x minus 1 cubed. What do we have to do from there? Yeah, use our power property to move those exponents. So this would be 3 log base 9 of x plus log base 9 of 2x plus 1 plus 3 log base 9 of 3x minus 1. Can any of those be simplified any further? Nope, so we're done. All right, go ahead and try number 2, please. Log of f cubed x times x to the 4th over y to the 1/3 power. Sorry. Nope, that's just an extra 2 right there. All right, check in with a neighbor. And then check your answer up here. Any questions about this one?
Could you put log over 3 for the last one?
Yes. Everyone okay? All right, let's practice condensing. So we have log base b of xy squared plus 2 times log base b of x over y minus 3 log base b of y times x to the 2/3. When you see something like this, you just have to take it step by step. Okay, we're going to break it down piece by piece. So the first thing we're going to do is move these coefficients and turn them into their powers. Okay, so that's going to be log base b of x y squared plus log base b of x over y squared minus log base b of yx to the 2/3. That whole thing is now cubed. My personal preference at this step is to go ahead and distribute these exponents so that we know what we're dealing with. So I'm going to rewrite this as that first log stays the same. When I have x over y squared, what does that give me? Good, that's x squared over y squared. And then what do I do with that 3, that cubed? If I want to cube y times x to the 2/3, I have to distribute that power. So this is going to become y cubed. And then what do I do with 2/3 and 3? Multiply them. Because when you have a power to a power, you multiply. So 2/3 times 3 is what? X squared. Everyone okay with that step? Okay? The next thing we're going to do is start condensing. Remember, when you're condensing more than one log, you have to work from left to right. Okay? We're just going to go step by step in order. So I'm going to go from left to right. So I'm going to start with these 2 logs. Which property do I need to use here? The product property. Good. So this is going to be log base b of, I'm going to have xy squared times x squared over y squared. Can I simplify that argument? Yeah, what can happen? The y squareds cancel, so what do I have left as my argument? So I have log base b of x cubed. And then are we okay if I just go ahead and bring this down? Minus log base b of y cubed x squared. Okay, now I'm going to keep condensing. So what rule am I going to use now? The quotient rule. So this is going to be log base b of x cubed over y cubed x squared. Can that simplify at all?
Yes.
Yeah, what can that give us? Okay, so log base b of x over y cubed.
What does simplifying and expanding these expressions like? Is there some another math we use these for? Is this like the math is expanding?
No, logs come into play. I mean, I think so. You're seeing them come into play in chemistry right now. You'll use them in calculus. So basically, right now, we're just getting really comfortable with all the operations so that you know how to work with them when you get to that higher stuff. Okay? All right. 2/3 log base 4 of 125 plus 2 times log base 4 of x plus 3 times log base 4 of y minus 1/2 log base 4 of 25.
If one of them is like, it's like the last one is like 3 log base 5, would that just, we have to like separate them? If like the last little part was like log base 5, would that just be like totally separate?
You could keep it separate, or you could.
You couldn't bring it together even if you didn't base it?
Oh no! Sorry, I thought you were saying, can you? Could you simplify? No. The properties that we learned yesterday only work with logs of the same base. Yes. Sorry, I was confused. All right. Start by dealing with your coefficients. Okay, what does 125 to the 2/3 power mean?
125 squared.
Yeah.
cube root of 125 squared.
All right, so the cube root of 125, that quantity squared. You could square 125, then take the cube root, but that's harder without a calculator. What is the cube root of 125? 5. And what's 5 squared? So this is log base 4 of 25. It's log base 4 of x squared. Plus log base 4 of y cubed. Minus. What is 25 to the 1/2 power? 5. All right, will you please go ahead and finish this problem? All right, check in with your neighbor, see if you match. You should have gotten log base 4 of 5x squared y cubed. You do need to simplify that 25 over 5 to become just a 5. Okay, let's talk about using these properties for some equations. So we've got log base 3 of 2 plus log base 3 of 7 equals log base 3 of x. So what we're going to do is condense the left side. So I'm going to have log base 3 of, what's 2 times 7? So log base 3 of 14 equals log base 3 of x. So when you've got an equation and you've got logs on both sides that have the same base, then the arguments must be equal. They have to be. So what does x have to be here? 14. All right, go ahead and try number 6, please. You guys talk about it. Fight it out.
You get m equals 5 divided by 5. Divided by 61.
Okay, what is 125 to the 1/3 power? 5. So this is log base 5 of m equals log base 5 of 5. I would recommend stopping here because you've got bases that are equal on each side, so your arguments must be equal. So what is m? 5. If you did turn this into a 1 and then set up an exponential equation, that's fine. Just remember, your goal is solving for m, not simplifying the right-hand side.
Oh.
Everyone okay? All right. Go ahead and work number 7 and 8. Guys, please stay quiet while people finish up. Yes, 7 and 8. Please stay quiet while people finish. Okay, number 7, what'd you get? 5. Anyone need help or would like to see that work? All right, what about for 8? 7. Anyone need help or need to see that work? Cool. All right, let's look at number 9. Go ahead and get this one copied down. All right, So in order to solve this, we've got to condense that left-hand side. And to condense that left-hand side, just like we've been doing, we've got to work from left to right. Okay? So if I look at this, I want to go ahead and just condense these first two. What rule do I have to use there? The quotient rule. So what does that tell me I'm going to do? 48 divided by 16 over 5, which I know is a little bit tricky. So instead of doing it like in my work, I'm just going to kind of go to the side a little bit, and I'm going to think about that. 48 divided by 16 fifths. How do I do that?
Flip the second number and hold it.
Keep change, flip. Good. 48 times 5 over 16. So think about putting this 48 over 1. What can 48 over 16 reduce? Yeah, what does that reduce into? Well, 16 goes into 48 3 times. So we have 3 times 5 is 15. So how do I condense these logs? What do I get? Log base 6 of 15. And then I'm going to bring down my plus log base 6 of 5 equals log base 6 of 5x. Everyone okay there? All right, what property are we going to use now? Product property. So I'm going to have log base 6 of, I can multiply out 15 times 5, but based on what I've got over here, it's kind of a waste of my time. Because I'm trying to figure out 5 times what gives me this number. Well, I already kind of know that now, don't I? What does x have to be? 15, because 15 times 5 has to equal 5 times 15. If you did multiply it out and get 75, that's fine. It's just a little short step. All right, please work number 10. Just try this one on your own without help from a neighbor. Yes, that's log base A of x equals 3/2 log base A of 9 plus log base A of 2. What does the 3/2 power tell you to do? What does any fraction power tell you? How do you get there? Which number tells you which one? The denominator tells you the root, the numerator tells you the power. I was trying to walk you through the process.
Bring up the contrast.
All right, look up here. You've got to remember a lot of these properties, guys. Some of y'all are really forgetting. What does 9 to the 3/2 power mean? The square root of 9 cubed. So the square root of 9 is 3. 3 cubed is 27. So this is 27 plus log base A of 2. So what am I going to do with my 27 and my 2? Multiply. So this is log base A of 54. So x is 54. Questions on that one?